This is a classic optimization problem in Calculus 1. We want to find the dimensions that minimize the perimeter of a rectangle given its area is 96 centimeters squared. I've gone ahead and drawn out the rectangle with a width of x and a height of y. So we know the area is equal to x times y, and that's equal to 96. And we also know that the perimeter is equal to 2x plus 2y because we add up all the lengths of the rectangle. Solving the area equation in terms of y, we get y equals 96 over x. This way we can plug it into the perimeter equation and reduce it to a single variable. So we have p of x is equal to 2x plus 2 times 96 over x. That's equal to 2x plus 192 over x. Now what we need to do is find the critical point for the perimeter function. So we need to take the derivative. We have p prime of x is equal to 2 plus, and let's do the derivative of 192 over x. So d over dx of 192 over x is the same thing as writing the derivative of 192 x to the negative 1, which can be written as negative 192 over x squared. So instead of plus here, we actually have a minus. So it's minus 192 over x squared. We go ahead and set this equal to 0 to find our critical point. Moving this over to the other side by adding on both sides, we get 2 is equal to 192 over x squared. Multiplying both sides by x squared, we have 2x squared equals 192. Dividing both sides by 2, we have x squared is equal to 96. So taking the square root both sides, we get x is equal to root 96. Root 96 is the same thing as 4 root 6. So now we have our critical point. Let's go ahead and draw a line with the critical point and then test over here and over here to look at the signs to see if we're actually looking at a minimum or not. P prime of something smaller than 4 root 6, would be 4, is equal to 2 minus 192 over 4 squared. And this is equal to 2 minus 192 over 16, which is negative 10. So we have a negative sign over here. Then let's look at something larger than 4 root 6. So p prime of 10 is equal to 2 minus 192 over 100 equals 2 minus 1.92, which is positive number. So you can imagine the function is decreasing and then it gets to 4 root 6 and then it goes back to increasing. So we have in fact found the minimum, or this minimizes the perimeter function. So we have x is equal to 4 root 6 and we need to plug in back to find y. We know y is equal to 96 over 4 root 6. So rationalizing, we just multiply top and bottom by root 6 and we have 96 root 6 over 24 equals 4 root 6. So we have that the rectangle, in fact, needs to be a square with 4 root 6 as the width and height. So that leaves answer choice D, I think, or 4, whatever the last answer choice is. And what we need to do is, since we're the farmer, is calculate the actual perimeter. So P is equal to 2 times 4 root 6 plus 2 times 4 root 6, which is equal to 16 root 6. And this is how much we need to ask for in fencing from our fence provider. So sweet. In this sort of problem, it actually turns out that if you want to minimize the perimeter of a rectangle with an area specified, you always want a square because you get the most area. Sweet. Hope you enjoyed this video.